Okay, welcome to lecture number 40. In last lecture we have proved different tests of similarity. 40 lecture has got a good amount of content. Let us begin with the first thing, practicing similarity. Given ABCD parallelogram, that means this side is parallel to this side and this side is parallel to this side, and point E is such that AE upon ED is given to be equal to M upon N, and different ratios are asked. Now when you have these two pairs of parallel lines, you have all these angles equal. This is alternate angle, therefore they are equal. These are also alternate angles, therefore they are equal. There are many angles which are equal in parallelogram if it is intersected by a line, and therefore there will be many similar triangles. Now the first question is AE upon BC. AE upon BC. Now if AE upon ED is MS to N, then AE upon AD is equal to AE upon AD, because BC is equal to AD in parallelogram. Therefore AE upon AD we want to find out, which is going to be M upon M plus N. Second question is AP upon AC. AP upon AC. AP upon AC, which is going to be AE upon AD. AP upon AC, no. AP upon AC, triangle APE is similar to triangle CPB. Triangle APE is similar to CPB. Therefore AP upon CP is equal to AE upon CB, and AE upon CB, which we have found out just now, is equal to M upon M plus N. Okay, and AP upon PC, that is what is this length, and AP upon AC is asked. Therefore by little bit of modification you need AC, so CP upon AP is equal to M plus N upon M. Now adding 1, CP upon AP plus 1 is equal to M plus N upon M plus 1, which is CP plus AP upon AP, which is 2M plus N upon M. Now what is CP plus AP? CP plus AP is AC. AC upon AP is equal to 2M plus N upon M, and therefore AP upon AC is M upon 2M plus N. Right? Area of AP. Third thing that is asked is area of APE upon area of ABCD. APE upon ABCD. Now this is little involved. APE and ABCD, area of ABCD. Suppose this area is X. Now if that area is X, what is the ratio PE upon PB? That is PE upon PB is equal to AP upon PC. PE upon PB, the third ratio, is AP upon PC, which is equal to M upon M plus N. Right? So PE upon PB is M upon M plus N, and if this area is X, so this Y area also will be X upon Y. Right? So Y is equal to, therefore Y is equal to X into M plus N upon M. Do you understand? Collinear base, common vertex, and therefore PE upon PB we wanted, which is equal to AP upon PC. AP upon PC is M upon M plus 1, and let us call this area Y, then X upon Y is equal to this, therefore Y is equal to this. right? Now, how much would this area be? That area will be equal to AE upon BC is the AE upon BC is the ratio of proportionality. Ratio of proportionality is AE upon BC, which is M upon M plus N. So area of PBC is upon area of say APE is equal to the ratio of similarity square, which is PBC. This upon this we are talking about, therefore M plus N upon M bracket square. This will be PBC upon APE, this ratio. And now the question which is asked is how much is this PBC? Therefore APE is X, therefore PBC is equal to X into M plus N upon M bracket square. So we got this area also. This area is also known, this area is also known. Now if you observe, ABC is half of parallelogram, therefore area of ABC is equal to area of ABP plus area of PBC, which is equal to area of ABP is Y, which is X into M plus N square upon M square. Sorry, this is the area. ABP is X into M plus N upon M plus this area X into M plus N upon M bracket square. This is the area ABC, and the total area is 2 times this, therefore area ABCD is equal to 2 times area ABC. And now in area ABC you find X, which is area of APE, therefore APE upon ABCD can be very easily expressed. Now exactly similar procedure is to be used. Now almost all of them are done, because we have found out APB, we have found out BPC, we have found out area of EPCD, and total area is also found out. So this is how we found out areas of opposite triangles using similarity ratio k square, and we found out area of triangles which are adjacent using collinear base and common vertex. These are the 2 important techniques that we need to use. That is the first part of today's lecture. Second, right angle triangle and a perpendicular is dropped. Then this distance is called X, this distance is called Y, this distance is called H. Side opposite to capital C is small c, opposite to capital V is small v, opposite to capital A is small a. And now we are supposed to write all similar triangles in this figure. This angle is also given to be equal to 90. So we can observe triangle ABC, A is 90, bigger and smaller, is similar to triangle DBA, is similar to triangle DAB. Why? Because suppose this angle is V, then this must be 90 minus V, which is U. This angle U, this angle V, U plus V is 90. Now this angle is 90, therefore this angle must be U and this angle must be V. So by AA test all these triangles are similar. Now if we write the ratio, we are supposed to find out AB square. So if we use these two, we get AB upon DB is equal to BC upon BA, which implies AB square is equal to DBC. Similarly, if we want, now AB square is done, AC square. So if I want AC square, if I want DA, this is wrong, DBA and DAC. So now if I want AC square, what should I do? I use these two triangles. So AB upon DA is equal to BC upon AC is equal to AC upon DC. Is that right? So if I use these two triangles, I get this similarity, and if I cross multiply, I get AC square is equal to BC into DC. Right? So now if I add AB square plus AC square is equal to BD BC plus DC BC, which is equal to BD plus DC times BC, which is BC square. So here we prove Pythagoras theorem using similarity. So if similarity is available, Pythagoras theorem's proof is absolutely simple. This is the proof which is included in board syllabus, and hence Pythagoras theorem is proved. And then once the Pythagoras theorem is proved, we can prove 1 upon b square plus 1 upon c square is equal to 1 upon h square. We have done this earlier in our lectures. You can go through them, or using this relationship and manipulating something, we can produce this. Basically what we get is c square is equal to xa, b square is equal to ya, h square is equal to xy. If we use these three relations, we will be able to deduce this quantity. This is what we call complete Pythagoras theorem. But why is it here? Because we have produced Pythagoras theorem's one proof using similarity. This is second part of today's lecture. Now the third part of today's lecture is converse of Pythagoras theorem. Suppose it is given a comma b comma c such that a square plus b square plus is equal to c square, and ABC are sides of triangle. If it is said like that, then triangle ABC is right angle at C. Okay, so this is a bit involved. Consider now this relationship is given to us, ABC. So now what we are going to do is we will construct a triangle. Now it is given that there exists a triangle with sides ABC and this relationship is existing. So now what we will do is we will construct, we will call this as C. We will take this angle as capital C. Now what is given to us is there exists a triangle whose this side is C, this angle is a B and C, and it is given that B, A and C behave like this, and we are supposed to prove that this angle is 90 degree. So what we do is we construct perpendicular, we cut a length of distance A here and call it as B, and we cut a length of B here and call this as A and join AB. Right? Now we have proved Pythagoras theorem, therefore this is right angle triangle which we have constructed, and hence this is going to be the side AB is equal to, using Pythagoras theorem, this will be A square plus B square. So AB is equal to radical A square plus B square, which is equal to radical C square, which is equal to C, and therefore AB in this diagram, let us call this as A dash B dash C dash, because we have constructed a new, this was given ABC. Now triangle A dash B dash C dash, side A dash B dash is also equal to C, therefore triangle A dash B dash C dash is congruent to triangle ABC by SSS, and hence angle A dash C dash B dash is going to be equal to major angle ACB, which is going to be equal to 90 degree, because this angle we have constructed 90 degree. That is the proof of converse of Pythagoras theorem. Converse of Pythagoras theorem has very limited number of proofs. Maybe this is the only one that we have. However, around 350, more than that, 350 proofs of Pythagoras theorem. Every new mathematician tries to give his own proof of Pythagoras theorem. That is how that theorem is celebrated. But for converse, this is the important and very important proof. So if we have three numbers, squares of 2 equal to the square of third, then and if they are forming a triangle, then that triangle must be right angle triangle. So that is the third thing in this lecture. The fourth thing is, if we happen to draw angle bisector of angle A, it intersects in D, then angle bisector theorem says in triangle ABC, if you draw angle bisector AD, then AB upon AC is equal to BD upon DC. The bisector, angle bisector divides opposite side in the ratio of adjacent sides. So AB upon AC is BD upon DC. This is what we are supposed to prove. We have around 3 different ways of proving it. We will discuss one. Maybe you try to do it independently. This is nothing to do with the Pythagoras result or the similarity, but this is BPT result. BPT is required for doing this. Now, let me show you one particular proof. AB upon AC is difficult, therefore what we do is we copy AC over here such that this distance is equal to this distance and join DC. Okay, so if we consider triangle ACD now, it is isosceles triangle and hence X is equal to X. Okay, and let me call this Y, Y and Y. Now, exterior angle of triangle ADC is BAC and therefore measure angle BAC is equal to measure angle ACD plus measure angle ADC, which is equal to 2y is equal to 2x, implies x is equal to y. X is equal to y. So if x is equal to y, this line is parallel, DC is parallel to AD. This implies DC parallel AD. Now this is a perfect situation for applying BPT, and therefore by BPT we get BA upon AD is equal to BD upon DC. However, AD by construction is AC, therefore BA upon AC is equal to BD upon DC. This is one way of doing it. There are two more methods by which we can do this. Maybe one by copying angles, by drawing a parallel line first and then showing isosceles triangle, and maybe third by measuring the same area in two different ways, because any point on angle bisector is equidistant from the arms. Therefore, if we draw perpendicular over here, the lengths of the perpendiculars h1 is going to be equal to h2. So area of triangle ABD, if we consider AB as base and h2 as height, then it is AB into h2 by 2 and AC as a base it will be. So I will consider area of triangle ABD upon area of triangle ACD. Then one way if I do it, it is half is cancelled numerator denominator, therefore AB into h2 upon 2 and this is AC into h1 upon 2. However, h1 and h2 are same, therefore this area is AB upon AC. But if I consider BD and DC, then there will be one height but which will be common. We know that it is BD upon BD upon DC, collinear base, common vertex. So these are three different ways of proving this theorem when it comes to internal angle bisector. And the last thing in today's lecture is external angle bisector, which is again similar to this. Let us look at that proof also. If we have an external angle bisector of triangle ABC, suppose I have a triangle ABC and this is external angle bisector and this intersects at D, then again the theorem is AB upon AC is equal to BD upon DC, BD upon DC. Okay, and now again let us do it using parallel lines, because that is what we have not. So let us assume that this is an external angle bisector, therefore those angles are YY, and now we draw parallel line to AD passing through C, let it intersect at K. Okay, now because these two lines are parallel, this angle is going to be Y, correct? And my diagram is not that good, but anyway, let me try. Okay, this point is K, this angle is Y, and by corresponding angles this angle is also Y. Therefore these two sides are equal. Can you see that? We are constructing this line which is parallel to this. By alternate angle test this is Y, and by corresponding angle test this is Y. Therefore these two sides are equal. What does BPT say? BPT says BK upon KA is equal to BC upon BD. Okay, rather writing BK. Okay, let us write BA upon AK, BA upon AK, BA upon AK is equal to BD upon DC, BD upon DC, because these two lines are parallel. So this is the extension of BPT that we have done. BA upon AK is equal to BD upon DC, but AK is equal to AC. BA upon AC is equal to BD upon DC. That is what we wanted to prove. So for exterior angle also, the angle bisector theorem continues to remain true. Now there is a little homework, but it is involved, which is complete meaning of similarity. If two triangles are similar, then their corresponding medians are also proportional, altitudes are proportional in radii, x radii, circumradii, distance between corresponding points like orthocenter, circumcenter, centroid, etc. Every corresponding distance is proportional to K. That is what is your homework. You try to prove this, and if we prove this, then we will be able to prove area of two similar triangles is proportional to K square, because base is side, so side upon side is K, and height upon height is also K. So that is what was required. Once you do this complete meaning of similarity, you will be able to complete that proof also. This was lecture number 40. Thank you very much. Let us meet in lecture number 41. Thank you.